Hi everyone, welcome to another video from Not Real Engineering. In this video, I am going to talk about a software called Neper. Neper is basically used for two things. One, to create microstructure, and two, to mesh that microstructure. This is the first tutorial video about this software Neper, so we will not go into much detail. In this video, we will basically see what this software is about, what it is used for. I will give you a quick introduction about this software, and then we will go through some basic examples using this software. Now before I start, let's go to Neper's website, which is mentioned over here. Now we are on the homepage of Neper's website, and Neper is an open source software, so you don't have to pay anything. Now first, to download and install the software, you have to go in this Downloads tab, and from here you can download the latest release, and also you can download the documentation. This is a very well written documentation, so you will find everything over here, starting from how to install the software. You can see over here all the instructions for installing the softwares will be given and how to test it if it is installed correctly or not. This is kind of tedious process. You have to install many dependencies before you install this software. I will not go through that in this video. Just follow the step-by-step process mentioned over here. Now I will install this software and we will get back into video. Now I have installed the software. One thing I want to mention is this software is not supported with Windows. So you have to use Linux, and I have Windows on my computer. So one way to get around is you can install Ubuntu app on Windows 10. So if you go in this search bar and type Ubuntu, you can find this Ubuntu app for Windows. And this is the best way to use Linux on your Windows system. Anyway, let's start with our introduction. Now Neper is divided into three modules. Now to generate a microstructure with mesh, which looks like something over here, you need to follow three steps. Step 1 is generation of microstructure. In Neper, that is called as module T. T stands for tessellations. And the meaning of word tessellation means an arrangement of shapes closely fitted together in a repeated pattern without gap or overlapping. So that's what we want. We don't want any gap between any two grains, or we don't want any grains to be overlapped as well. And you can see over here the use of word tessellation increased drastically after 1950s. And I guess that's the time when we started to pay much more attention to the microstructure of materials. You will get many different options to create microstructure, such as from morphological properties, or you can even create multi-scale microstructures, which means you can create some microstructure and then you can refine it even further. You will have option of periodic or semi-periodic tessellations as well, and you can assign crystal orientation also. So for each and every grain, you can assign some crystal orientation. Next step is meshing, which is called as module M in Neper. Once you have your microstructure, you can mesh it with many other options. You can choose element size, you can choose element shape, you can also do remeshing, or you can do mesh partitioning as well. And lastly, step 3 is visualization. So when you use these first two modules, module T and module M, you will not visualize what you are doing. It will just create some files, but you can't see that. So to visualize what you did, you have to use module V. And using module V, you can create such pictures. In module V, it's like you are taking a snapshot from some angle. So you can locate your camera, which angle you want, and you can adjust color, transparency, etc. You can even take sections, and then you will click a snapshot. And Neper produces publication quality pictures. So only downside of Neper is it doesn't have 3D visualization module. Always you have to click a snapshot and then see what you are doing. So you will not get a 3D image of this, which you can rotate in any direction in a dynamic environment. So that will not happen. You have to always go with a image, 2D image. Now let's run few basic examples. So I have installed Neper in my Ubuntu app, and I have created one folder called Neper in C drive, and I will go to that folder using this terminal. Now whatever we work over here, we will create all the files in this location. First, let's create one 3-dimensional microstructure as shown over here. To create that, you just have to type this command, Neper/T/N10. Command Neper will call that software. /T is the module. Using command /N, we can assign how many grains we want. So this will create 10 grains, and just hit enter. And you will see one .tess file is created, which has our microstructure. Now, as I said, you will not able to see this unless you use visualization module. So to use visualization module, you have to type this third command. Now this V will call visualization module. Here you have to give input file name. This is our input file. /print will create your image, and this is just an image name. You can give any name, whatever name you want over here. And then if you hit enter, you can see the image is created. Let's check. And this is the microstructure with 10 grains. Of course, you can adjust many things like dimensions of RVE, how many number of grains you want, etc. But that we will see in later videos. Now next thing is to mesh it. For meshing, you have to use this command. Again over here, this M stands for mesh module, and again input file, our .tess file. And here you can define element type. I'm defining the type as hexagonal. And once you do this, you will see one more file, which is .msh file. And this will have your mesh. Now again, if you want to visualize the mesh, you have to type this command. Over here, you have to give input of two files. One will be your .tess and one will be .msh. So let's do that. Now we'll print it into image 2. And you can see one more image over here, which has mesh. Now you can select element size as well. If you want to select element size, you just have to select it using this command. So I will show you one more example. Instead of this second line, we will replace it with this line. And again, we will visualize this. This is the same as this last line. So same command for mesh, and we will select element size from /rcl, let's say 0.5. And you will see this mesh file is updated, and we can visualize it again using same command. Only the image name I will change to image 3. And if you open this, you can see it is much finer mesh. This was the earlier one. This is the new one. Now one more example I have showed over here where we have 100 number of grains. Everything is same, just number of grains is increased to 100. You can try out this example as well. And if you want 2D microstructure instead of 3D, you just have to define over here /dimension /dim to 2. Sorry for my handwriting. We can see one more example with 2D microstructure. So first you have to again use same T module and /dim 2. Let's mesh that as well. And one more good thing about Neper is all the commands have some default value. Means if you did not define element type, it will select some element type by default. So I did not define element type over here, and still it selected some element type, and .msh file is updated now. Let's visualize how they look. I will change it to image 4. And this is the 2D microstructure with 10 grains. I guess that's enough for first video. It was just introductory first tutorial. In future videos, we will do some more complex examples. As you can see over here, we can have cylindrical domain or spherical domain. We can solve some example with different element types. When you mesh complex geometries, you will definitely run into some problems. The mesh will fail and Neper will give some error. So we'll discuss those problems as well. Then we can even see some example with more complex shapes like this, and many different types of microstructures we can generate. And finally, we can also look at how to assign crystal orientations and how to get these pole figures. Now I know there are no video tutorials out there about this software Neper, but I'm not sure how many people actually use this software. So if you are interested, please let me know in the comment section. And if I get enough comments, I will definitely make these future videos. If you like this video, please show your support by subscribing to this channel, which will give me motivation to create more educational videos like these. You can also go to channel's playlist tab, and here you can see all the videos with similar topics combined together. For example, let's say if you're interested in ANSYS tutorials, you can go to this ANSYS tutorial playlist and see all the videos from this playlist. All the codes and files which I use for these videos are also available for you to directly download from this channel's GitHub profile. The link of this profile is given in the description box below. If you have any questions, please let me know in the comment section below. And as always, thank you for watching.